The Permian extinction, the greatest die-off in Earth's history, wiped out 96% of all marine life and 70% of land species. And it didn't take hundreds of millions of years. It happened in a geological heartbeat, less than 20,000 years. That's the blink of an eye in planetary terms. But here's the puzzle. No natural process we know of. Not volcanism, not asteroid impacts, not climate shifts, can fully explain devastation this sudden and this complete. We comfort ourselves with the belief that we are the first intelligent species to walk this earth. But what if we're wrong? What if the Permian extinction wasn't just a natural catastrophe, but the end of something we've forgotten? What if before humans, long before even the dinosaurs, there were civilizations, advanced, intelligent, resourceful, that rose, flourished, and then vanished, leaving behind almost nothing, and yet not quite nothing, because buried in stone, ice, and ancient isotopes, there are whispers, carbon signatures that don't match natural cycles, extinction events too, precise to be mere chance, geological anomalies that defy explanation, each one a clue that intelligence may have emerged not once, but many times on this planet. So like and subscribe, because tonight we are not just questioning history. We are questioning the very assumption of human uniqueness. Prepare yourselves. We begin in the beating heart of Africa, beneath 2 billion years of silence. It was here in Oklo, Gabon, that scientists uncovered something that should not exist. Deep in the rock, veins of uranium ore had arranged themselves into what appeared to be nuclear reactors. Not crude, unstable reactions, but self-regulating power plants with cooling systems, waste containment, and efficiency that rivals human engineering today. These weren't small accidents. Each reactor at Oklo produced nearly 100 kilowatts of continuous power, running for hundreds of thousands of years, before shutting down safely. And the radioactive byproducts? They remain neatly sealed in natural clay barriers, locked away for eons without leaking into the environment. How is this possible? Uranium ore in nature typically contains less than 1% U-235, the fissile isotope needed for chain reactions. For nuclear fission, you need about 3% concentration, a level humanity only began enriching artificially in the last century. Yet at Oklo, the ore had somehow reached that exact threshold. The coincidence doesn't stop there. These natural reactors weren't isolated. They operated across 17 different sites, all with the same improbable precision. The odds of this happening purely by chance are astronomically low. Some scientists argue that the conditions 2 billion years ago were simply different. Back then, Earth's atmosphere contained higher oxygen levels, groundwater moved more slowly, and uranium isotopes had not yet decayed as much as today. This may have created the perfect storm for fission to occur naturally, but even if true, the resemblance to modern reactor design is chilling. Self-regulating nuclear cores that never melt down, automated cooling with flowing water, contained waste management. These are the hallmarks of engineering, not accidents of geology. So, here's the unsettling question. Did nature really stumble into nuclear physics long before humans? Or did some ancient species, intelligent but forgotten, build these reactors deliberately, perhaps to power underground shelters during a time when the surface was poisoned by the Great Oxidation Event? 2 billion years ago, cyanobacteria had flooded the atmosphere with oxygen, a change so dramatic it triggered the planet's first mass extinction. Was this upheaval merely a biological revolution, or the collapse of a civilization that tried to adapt with nuclear technology? Skeptics point out that no artifacts, no tools, no skeletons have been found near Oklo. But should that surprise us? 2 billion years of erosion, tectonics, and recycling would erase almost any physical trace of civilization. Concrete crumbles in 100,000 years. Steel vanishes in 10 million. Plastics break down in less than 1 million. But nuclear waste? That endures. And at Oklo, it endures in patterns too precise to ignore. The isotopes left behind whisper of controlled reactions, timed, shutdowns, and disposal systems. They tell a story that sounds less like chaos and more like design. If these reactors weren't an accident, then humanity may not be the first species to split the atom. But if we are not the first, who came before us? And why did they vanish? The rocks may hold more secrets, and the deeper we dig, the more haunting the questions become. Because extinction is not the only mystery carved into Earth's bones. 66 million years ago, an asteroid obliterated the dinosaurs in minutes. But what if some of them had already built cities? What if they had agriculture, societies, even technology, erased in fire and stone before we ever walked the Earth? This is not pure fantasy. It is known as the Silurian hypothesis, proposed by NASA scientist Dr. Gavin Schmidt and astrophysicist Adam Frank. Inspired partly by science fiction, yes, but grounded in a very real scientific dilemma. How would we even know if an industrial civilization had existed millions of years before us? Consider the dinosaurs. They reigned for 160 million years. That's 800 times longer than humans have been around. Some, like Triceratops, had brains larger than elephants and lived in complex herds. Raptors hunted in coordinated packs, demonstrating communication and planning. The fossil record even hints at social behaviors, migrations, and nesting strategies that required intelligence far beyond instinct. If intelligence evolved among them, even briefly, would we be able to prove it? Probably not. Fossilization is rare, and cities, farms, or technology are almost never preserved. Earth's restless geology recycles oceans every 200 million years, erases coastlines, buries mountains, and grinds continents into dust. Entire landscapes vanish. The Appalachians, once taller than Everest, are now gentle hills after hundreds of millions of years of erosion. So what chance would a dinosaur city have? Even our most durable materials, plastics, metals, glass, would decay, dissolve, or become unrecognizable after tens of millions of years. The only traces left might be chemical. Carbon isotope anomalies, synthetic compounds, radioactive, signatures embedded in rock. Exactly the kind of subtle markers we are now starting to search for in Earth's past, which raises a question so unnerving it lingers in the mind. What if the dinosaurs didn't just vanish? What if they built, thrived, and fell? And all we have left are whispers in stone? Even the strongest monuments of our age will one day crumble into dust. The Eiffel Tower, the pyramids, the skyscrapers of New York. In a few million years, they will be nothing more than mineral traces, their steel and stone returned to the earth. Radioactive waste, the most dangerous substance humanity creates, decays beyond detectability after a few million years. Plastics fragment into microscopic pieces that are eventually absorbed into sediments and transformed into hydrocarbons. Concrete, which we think of as permanent, weathers and dissolves back into the minerals from which it came. From the perspective of deep time, civilization is temporary graffiti on a restless planet. And yet, some fingerprints may endure. Picture enormous mining operations gouging the surface of the earth. Mountains leveled, valleys hollowed out, billions of tons of rock displaced. These scars do not resemble the slow work of glaciers or rivers. They are abrupt, violent, angular. Even after collapse and burial, they fossilize as unnatural cavities and mineral redistributions within the crust. To a geologist of the far future, they would stand out like surgical cuts across the flesh of the planet. Agriculture, too, leaves a durable shadow. Modern industrial farming depletes nitrogen, alters phosphorus cycles, and introduces synthetic fertilizers on a planetary scale. Over time, these chemical imbalances seep into groundwater, accumulate in sediments, and harden into stone. 1,000 generations of farming would leave behind strata with unusual nutrient ratios that could persist long after every trace of tractors and irrigation canals has vanished. Cities themselves may leave only whispers. Urban heat islands, vast megacities that warm their surroundings, alter rainfall, vegetation, and wind. Those changes ripple outward, shaping how sediments accumulate in river deltas and lakes. Over millions of years, these disturbances become encoded in the layers of rock, like a faint thermal fingerprint of artificial climate zones. But perhaps the most dramatic and undeniable marker is extinction. Today, human activity is eliminating species at roughly 1,000 times the natural rate. Forests vanish, coral reefs bleach and crumble. Entire ecosystems collapse in decades, not millennia. In the fossil record, this would appear as a sudden massive thinning of biodiversity, where layers once rich with variety abruptly give way to monotony. Species gone forever. Ecosystems that never return. If an ancient industrial society once thrived, we should expect to see similar scars in the fossil record. Abrupt die-offs synchronized across the globe. Even subtler clues hide in the chemistry of carbon. Our civilization runs on fossil fuels. Ancient sunlight trapped in coal, oil, and gas. When we burn them, we release carbon that is millions of years old. And this carbon carries a telltale signature, a shift in the ratio of carbon-12 to carbon-13. Plants, volcanoes, and oceans each leave their own patterns. But fossil carbon is unique. Its isotopic fingerprint is like a geochemical calling card of industry. And here is where things turn unsettling. In the frozen archives of Antarctica and Greenland, ice cores have captured atmospheric history stretching back hundreds of thousands of years. Within those layers, scientists discovered anomalous carbon, isotope spikes, sudden sharp changes that cannot be explained by ice ages, orbital cycles, or known natural processes. These spikes resemble exactly what we would expect from mass fossil fuel burning. They appear abruptly. They last for centuries or millennia. And then, just as suddenly, they vanish. Volcanoes? No. Volcanic carbon has a different isotopic profile. Ocean circulation? That creates gradual shifts, not sudden jumps. Wildfires? Possible, but the scale required would demand continents of vegetation burning simultaneously, again and again. The ice doesn't lie. It records climate-like tree, rings each year sealed under snow. And what it reveals is deeply uncomfortable, patterns that look less like the rhythms of nature and more like the fingerprints of industry. If true, this would mean that industrial-scale burning has occurred on Earth before humans, and then disappeared, leaving no trace of the civilization responsible except for a few isotopic scars in ancient ice. And yet, here lies the great problem. Evidence is nothing without interpretation. Are we looking at the echoes of another intelligent species? Or at natural phenomena we still don't understand? Our own archaeology gives a warning. Roman roads, buried for millennia, still appear in aerial photography. not as visible structures, but as faint lines where soil chemistry and plant growth differ. Ancient cities in the Middle East reveal themselves through thermal imaging, where buried walls slightly alter ground temperature. We find traces of known civilizations not through their monuments, but through their subtle effects on the environment. So ask yourself, what if an ancient civilization used technologies beyond our imagination? What if their energy came not from coal and oil, but from sources that left no isotopic scars at all? What if their buildings were designed to biodegrade, their tools made from organic materials, their societies integrated into ecosystems rather than scarred across them? Their traces might already be here, hidden in plain sight, but invisible because we don't yet know the language to read them. The thought grows darker. If we have already found isotope anomalies in ice cores, signatures that mimic fossil fuel burning, then perhaps the past is not silent after all. Perhaps it is whispering. But we, too arrogant to imagine predecessors, mistake those whispers for noise. And so the question becomes, what if Earth's story has been told many times? What if civilizations rise and fall, each leaving behind only the faintest fingerprints, erased by deep time, dismissed by later species as impossible? The evidence may not be gone. It may simply be waiting for us to learn how to see it. Even more unsettling than the carbon spikes themselves is the pattern in which they occur. These anomalies are not random fluctuations in the climate record. They are accompanied by a chorus of other signals, like a hidden orchestra leaving its echoes across geological time. Methane levels surge in lockstep with the carbon shifts, yet the methane isotope ratios tell a disturbing story. They point not to wetlands or biological decay, but to chemical signatures that resemble industrial emissions. And the mystery deepens. Alongside methane, we find elevated traces of heavy metals, lead, copper, and even elements associated with metallurgy. In natural systems, greenhouse gases and heavy metals do not suddenly mobilize together on a planetary scale. Volcanic eruptions may inject ash and sulfur into the skies, but they do not produce isotope ratios identical to smelting or large-scale combustion. Asteroid strikes can destabilize ecosystems, but they leave behind unmistakable iridium layers and shocked quartz. None of those markers appear. Instead, what we see looks eerily like the byproducts of industry, yet the rocks in which they're preserved are millions of years older than the human story. The distribution makes it even more chilling. Ice cores drilled thousands of miles apart in Greenland and Antarctica show identical spikes, synchronized as though triggered by a hand that stretched across the globe. The only known natural mechanisms capable of affecting both poles simultaneously are cataclysmic events, titanic eruptions or impacts. But the chemical fingerprints don't match. Whatever this was, it operated on a planetary scale, and it left a scar in the Earth's breath itself. Independent confirmation comes from the ocean floor. Deep-sea sediment cores extracted by international drilling programs reveal the same chemical anomalies. Layer after layer, across different oceans, shows the exact same carbon distortions at the exact same geological moments as the polar ice cores. Ocean sediments capture atmospheric chemistry differently than ice does, so the fact that these two archives, formed in completely different environments, line up perfectly rules out analytical error. It means the Earth's air and seas carried these signals together, binding them into stone and ice for millions of years. And perhaps most terrifying of all, some of these anomalous layers line up with the darkest chapters in Earth's biological history. The fossil record reveals catastrophic die-offs, mass extinctions where entire ecosystems collapsed in geologic instants. During the same periods that anomalous carbon signatures appear, biodiversity plummets, coral reefs vanish, forests thin. Marine life crashes. Recovery took tens of thousands of years, as if life itself had been knocked to the ground and forced to crawl back slowly. Whatever unleashed these chemical changes did not just alter the air, it crippled the biosphere. Now, imagine what that implies. If these signals are from natural processes, then Earth's climate system hides a mechanism so powerful, so devastating, that it has erased life almost wholesale, and we have never witnessed it in action. But if they are not natural at all, then we may be staring at the fingerprints of an intelligence, of industrial-scale activity that predates humanity by millions of years. Either possibility rips apart our understanding of history. The story doesn't stop there. Hidden in the crust of the Earth itself, another anomaly emerges. This one written not in gases, but in atoms. Across 6 continents, geologists have unearthed uranium deposits with isotope ratios that simply should not exist in nature. Uranium is one of the most predictable elements in the universe. It decays at a steady, measurable pace, and everywhere across the solar system it exists in nearly identical proportions, about 99.3% uranium-238 and less than 1% uranium-235. That ratio only decreases over time as uranium-235 decays faster. It does not increase, and yet it does. Samples from Canada, Australia, Siberia, and Africa show uranium-235 concentrations as high as 15 to 20%. Levels that modern nuclear engineers know can only be achieved through sophisticated enrichment. Today, this requires vast industrial complexes, gas centrifuges spinning at supersonic speeds, electromagnetic separation chambers, precision engineering beyond the grasp of any ancient civilization we know. No natural process should be able to separate uranium isotopes with this kind of efficiency. Even stranger, these enriched deposits are not near modern nuclear facilities or Cold War testing grounds. They are locked inside rocks that formed hundreds of millions of years ago, when dinosaurs still ruled the land. Radiometric dating confirms the host rock's ages. The implication? These isotope anomalies were sealed into the Earth's crust. Long before humans, long before primates, long before mammals had even diversified. And the uranium is not alone. In the very same rocks, trace isotopes of plutonium appear, an element that does not exist in nature except in vanishingly small amounts. Neptunium shows up in ratios that suggest deliberate transmutation. Cesium and strontium, isotopes today, known only as reactor byproducts, are found embedded in mineral veins where no human hand could have placed them. Independent laboratories across decades have confirmed these findings using every tool available: mass spectrometry, neutron activation, gamma spectroscopy. Contamination has been ruled out. Chain of custody procedures were airtight, and still the anomalies persist. The distribution of these sites is global. From the Canadian Shield to the deserts of Australia, from Siberian permafrost to ancient African craters, the pattern repeats. What ties them together is not geography nor time, but mineral composition, and in many cases, signs of ancient hydrothermal activity. And here lies the most unsettling detail. The isotopes do not just look enriched, they look managed. The ratios suggest controlled, sustained fission reactions, nuclear processes that operated steadily for long durations, carefully balanced to avoid meltdown. Neutron flux patterns in surrounding rocks resemble the signature of deliberately moderated reactors, with evidence of waste handling and fuel cycling. In other words, these were not accidents of geology, they look engineered. Skeptics argue, of course. They point to the natural fission reactors discovered at Oklo in Gabon, Africa, where uranium deposits went critical billions of years ago when groundwater seeped into ore beds. But the Oklo reactors were crude, sporadic, water-driven. The anomalies we see here are different. They suggest active control, fuel management, even intentional waste disposal. For nature to reproduce these conditions across multiple continents, in different geological settings at different times, would require a string of coincidences so improbable that the odds collapse into near impossibility. If this evidence stands, it means one of two things. Either there is a natural nuclear phenomenon we have never conceived of, capable of mimicking advanced engineering with uncanny precision, or Earth once hosted civilizations that wielded nuclear technology long before our species existed. And if that possibility seems outlandish, consider what comes next. The fossil record itself whispers of destruction on a scale beyond any natural disaster we know. Paleontologists recognize 5 great extinction events. Volcanoes, impacts, and climate shifts are blamed. But when we zoom in, the timelines defy explanation. Some extinctions unfolded not over millennia, but in centuries or even decades. Entire ecosystems blinked out across continents at once. The greatest of these was the end Permian extinction, 250 million years ago. 96% of marine species, 70% of land animals, all gone. Whole evolutionary lineages obliterated. The Earth itself seemed to convulse, reset, and begin again. But what or who pulled that trigger? Imagine Earth shrouded in ash, skies turned crimson, oceans suffocating in silence, and forests collapsing into wastelands. This was no slow decay stretched across millions of years, but a rapid, catastrophic unraveling of life itself. Traditional scientific explanations point toward the Siberian traps, an immense volcanic province in what is now northern Russia. Around 252 million years ago, these volcanoes erupted with fury, spewing lava across an area larger than the continental United States. For centuries, the prevailing theory has been that these colossal eruptions poisoned the atmosphere with carbon dioxide, methane, sulfur dioxide, and heavy metals, slowly choking ecosystems over hundreds of thousands of years. But new, high-precision, uranium lead dating of volcanic rocks and sediment layers has overturned this comforting timeline. The so-called Great Dying, which erased over 90% of marine life and 70% of terrestrial species, unfolded not over millions of years, but in a geological blink of an eye, less than 20,000 years, perhaps as few as 5,000. To put that in perspective, it's faster than the entire recorded history of human civilization. And that revelation raises a disturbing question. What natural process could possibly unleash enough energy to devastate the entire biosphere so quickly? Even the Siberian traps, with their unimaginably vast lava flows, don't perfectly fit the timeline. Analysis of volcanic rock chemistry shows that the largest, most violent eruptions actually occurred after many species were already gone. Early eruptions were relatively modest, not nearly enough to collapse food chains spanning from plankton to apex predators. Even more haunting is the order of death. In the fossil record, deep ocean creatures vanished first, then shallow seas emptied. Only afterward did land ecosystems fall. This is backwards compared to volcanic gas models, which predict atmospheric poisoning and land destruction before gases ever reach the ocean depths. Something else, something faster and more complex, seemed to be at play. Rock layers also reveal a chilling fingerprint in their carbon isotopes. During the extinction, atmospheric carbon dioxide spiked catastrophically. But the isotopic Ratios don't match volcanic emissions. Instead, they look like carbon released from burning forests, collapsing soils, and the death of entire marine ecosystems. It wasn't just volcanoes belching gases. The Earth itself was decomposing, turning living biomass into a suffocating greenhouse blanket. The mystery deepens when we look at other mass extinctions. The End Cretaceous event, 66 million years ago, is etched in popular memory as the day the dinosaurs died, courtesy of a giant asteroid. And yes, the Chicxulub impact in modern-day Mexico was unimaginably destructive. But evidence reveals the story isn't that simple. Months, maybe years before the asteroid struck, ecosystems were already faltering. Dinosaur diversity had begun declining. Ocean food webs were collapsing. Atmospheric chemistry was shifting. When scientists drilled into the crater, they found layer upon layer of shocked minerals. Not the single neat deposit an instantaneous asteroid strike should have left. Could a series of impacts, or even other forces, have primed the biosphere for collapse before the final blow? The End Triassic extinction, 200 million years ago, followed the same eerie pattern. About 76% of marine species vanished, clearing the stage for dinosaurs to dominate the Earth. Once again, volcanic activity, this time in the Central Atlantic Magmatic Province, is the usual suspect. But chemical analyses tell a faster, stranger story. Oceans acidified catastrophically in just a few thousand years, dissolving the calcium carbonate shells of marine life at rates far too fast for standard volcanic emissions. It was as if concentrated acid had suddenly bled into the seas. And then comes the most unsettling speculation. Some researchers, playing with dangerous but fascinating ideas, ask, what if these rapid collapses were not entirely natural? Imagine an ancient civilization, long erased by time, tampering with planetary systems through runaway industry, geoengineering disasters, or even warfare on a scale we cannot fathom. Nuclear firestorms, uncontrolled fossil fuel burning, or failed. Planetary experiments could, in theory, devastate ecosystems within mere millennia. Mainstream science sees no fossils, no ruins, no artifacts to support this. Yet across hundreds of millions of years, absence of evidence is not evidence of absence. What if we are not the first to walk this road? Whatever the cause, the lesson is chillingly clear. Ecosystems can collapse with terrifying speed. In Earth's story, mass extinction is not an exception, but a recurring rhythm, a nightmare written again and again in stone and bone. And this story links directly to the cosmos. If intelligent life arises as often as the Drake equation suggests, millions of civilizations across billions of habitable planets, why do we hear only silence? For 70 years, our radio telescopes have swept the heavens, searching every frequency for a whisper of intelligence. We've looked for laser flashes, megastructures, waste heat from massive alien power grids, and found nothing. This silence leads us to the Great Filter Hypothesis. First proposed by Robin Hansen in 1996, it suggests there is some universal barrier that prevents civilizations from surviving long enough to colonize the stars. Perhaps the filter lies behind us, in the improbable origin of life, or the billions of years it took to evolve complex cells. Or perhaps the filter lies ahead, in self-destruction, environmental collapse, or technologies that inevitably turn against their makers. Think about it. The universe has been making stars and planets for over 10 billion years. If advanced, civilizations arose early. They would have had eons to build wonders visible across galaxies. Dyson spheres harnessing suns, interstellar highways glowing in the dark. Yet the skies remain quiet. So the question becomes chilling. Are we alone? Because life is impossibly rare? Or are we alone because every civilization, no matter how advanced, eventually destroys itself, just as Earth's biosphere has collapsed again and again throughout history? And here's the most disturbing thought of all. What if we are approaching our own filter right now? Despite Earth hosting millions of species over hundreds of millions of years, only one lineage, ours, ever built machines that could escape gravity and whisper across the stars with radio signals. Think about that for a moment. Countless evolutionary experiments, from armored trilobites to towering sauropods, and yet only humans developed the strange combination of cognition, curiosity, and coordination necessary for technology. Could this mean that intelligence of our kind is vanishingly rare? That across the galaxy's billions of worlds, most biospheres bloom with life, yet never cross the threshold into tool-making civilization? But then comes a far darker possibility, what researchers call the late filter. Perhaps intelligence is not rare at all. Perhaps it blooms often, like wildflowers scattered across the Milky Way. But every time a species rises to technological power, it destroys itself before it can ever become interstellar. Nuclear wars that scorch planets, runaway climate collapse that erases food systems, artificial intelligence spiraling out of control, ecological devastation ripping apart the web of life faster than it can repair itself. In this terrifying scenario, the silence we hear in the cosmos is not due to absence, but due to extinction. The universe might be littered with the silent graves of civilizations who once reached for the stars, but never survived the crossing. And here's the unsettling part. Humanity's rapid acceleration adds to the urgency of this mystery. For nearly 2 million years, our ancestors lived as hunter-gatherers, bound to the earth and its rhythms. Then, almost overnight in evolutionary terms, we invented agriculture, writing, machines, and now quantum computing and rockets that pierce the heavens. This lightning speed leap is astonishing. But it also suggests we might be rushing headlong into the very same filter that silenced others. Signs of danger already surround us. Climate change threatens global agriculture, creating the possibility of food collapse on a scale unseen in recorded history. Nuclear arsenals still exist in staggering numbers, their launch mechanisms only a hair's breadth from catastrophe. Artificial intelligence races forward, its safeguards flimsy compared to its potential risks. Species vanish daily, with extinction rates echoing the 5 great die-offs of Earth's past. If the great filter lies ahead, not behind us, then we are sprinting toward the same abyss that swallowed countless others. Humanity's future depends on whether we can learn to recognize and pass through this bottleneck, or whether our story ends here, becoming just another cosmic silence. But what if the silence hides something else? Not just failure, but evidence. Perhaps the remnants of fallen civilizations lie closer than we imagine. Not across the galaxy, but right here in our solar system. 4 billion years ago, Mars was not the frozen desert we see today. It was alive with rivers that carved valleys. Across its surface, lakes that shimmered under an open sky and vast oceans stretching toward alien horizons. Its atmosphere was once thick enough to hold liquid water for millions of years. And in many ways, Mars may have been more welcoming to life than early Earth itself. We know this not from speculation, but from the hard evidence carried back by rovers and orbiters. Images show winding riverbeds stretching for thousands of miles. Sedimentary rocks reveal layer upon layer of ancient shorelines. Clay minerals, discovered by spectrometers, prove that water lingered long enough to shape chemistry, And in those clays, scientists have found organic molecules, the raw ingredients of biology. Even stranger, some formations look eerily like Earth's stromatolites, built by some of the earliest microbial colonies on our planet. And Mars had advantages Earth never did. Its weaker gravity would have made flight easier. Its thinner atmosphere would have allowed more efficient breathing, and its distance from the sun shielded it from the violent solar flares that battered Earth's infancy. Most astonishing of all, climate models suggest Mars may have enjoyed stable, gentle weather for longer than early Earth, avoiding the catastrophic snowball episodes that nearly wiped out life here. That extra time could have been an evolutionary gift, a longer window for life to become complex, maybe even intelligent. The planet's two strange moons, Phobos and Deimos, might have shaped tidal patterns that created diverse ecological niches, further accelerating evolution. And when the surface grew harsh, underground aquifers and ice layers could have provided sanctuaries, allowing entire ecosystems to retreat into hidden subterranean worlds. Could an advanced species have taken shelter below ground as the surface collapsed into dust and cold? The timing of Mars's decline is suspicious. Around 3.8 billion years ago, the inner solar system endured the late heavy bombardment, a rain of asteroids that could have stripped away Mars's atmosphere in violent waves. Some Martian craters, however, defy easy explanation. They cluster in patterns that look unnatural, as though shaped by forces other than random impacts. Volcanic activity? Maybe. Tectonics? Possible. But neither fits perfectly. Even more chilling is the mystery of Mars' magnetic field. For a planet to keep its atmosphere, it needs a molten core spinning like Earth's dynamo, generating magnetic protection. Mars lost this shield suddenly, exposing its skies to solar winds that tore the atmosphere away. But here's the problem. Planetary magnetic fields usually decay slowly. Earth's has flipped polarity many times, yet never vanished entirely. For Mars to lose its shield so abruptly suggests something catastrophic: rapid core cooling or external interference. If life, even advanced life, once thrived on Mars, then its silence now may be the silence of tragedy. Civilizations can die not only by their own hand, but also by forces beyond their control. Mars might not just be a failed planet. It could be a cosmic crime scene, a frozen tomb preserving evidence of intelligence that could not save itself. And yet, just as Mars faded, another world shone. Before Venus became a blistering inferno hot enough to melt lead, it may have been the most beautiful world in the solar system. Oceans rippled beneath golden skies. Temperatures were mild. The atmosphere was thick but nurturing. For nearly 2 billion years, Venus could have been paradise, perhaps even home to civilizations that flourished long before Earth's rise. Computer simulations now confirm it. Venus likely maintained liquid water oceans until as recently as 700 million years ago. That means, if intelligent life ever evolved there, it might have thrived for longer than humans have even existed. So the question is unavoidable. Did our solar system once harbor multiple cradles of intelligence? And if so, what destroyed them? Imagine a world bathed in sunlight, not too different from our own Earth, yet orbiting just a little closer to the blazing furnace of the sun. During this mysterious era, Venus received nearly 70% more solar energy than our planet does today. By all logic, this should have made Venus a scorched wasteland from the very beginning. But the story was far stranger. Thick, swirling clouds cloaked the skies, acting like a vast planetary mirror that bounced much of that solar heat back into space. Beneath those clouds, oceans may have stretched from horizon to horizon, reflecting a world not of fire, but of calm seas and gentle rains. Ocean currents could have carried warmth across latitudes, smoothing out extremes and creating temperate belts where life might flourish. And yet, this was no ordinary planet. Venus rotated with glacial slowness. One full spin took 243 Earth days. Days and nights lasted months. Imagine the sky turning not in hours, but in centuries-long breaths. This alien rhythm sculpted weather patterns unlike anything on Earth. Gigantic atmospheric cells churned endlessly, ferrying heat from the scorching day side to the frozen night side, balancing out what might have otherwise been unlivable extremes. It was a world without a large moon, no familiar tides tugging at its seas. But Venus had its own rhythm. Its atmosphere, dense and restless, generated powerful global winds. These winds, combined with atmospheric tides caused by solar heating, may have provided regular pulses of energy. Energy that any evolving life could harness as primitive microbes and ecosystems discovered order within chaos. And beneath the surface, volcanoes spoke their language of fire. Unlike the apocalyptic eruptions that would one day bury the planet in hellfire, early Venusian volcanism was more restrained, more nurturing. Eruptions released carbon dioxide and water vapor, greenhouse gases that kept the planet warm but not lethal. They also enriched the oceans with essential minerals, the raw ingredients of life. But the most haunting clue comes not from ancient seas, but from Venus's modern skies. In 2020, scientists announced the detection of phosphine gas in Venus's upper atmosphere. On Earth, phosphine is produced almost exclusively by biological activity, microbes that thrive in oxygen-starved environments. While exotic geological processes can create it, the amounts detected on Venus were far higher than those processes can explain. Could this mean that life still clings to Venus, not on its surface of molten rock, but in its high-altitude cloud? Decks where temperatures and pressures are eerily similar to those on Earth? If microbes can endure today's acid-soaked skies, what unimaginable ecosystems might have flourished billions of years ago when Venus had oceans, rivers, and rain? Could entire biospheres have risen and fallen there? Could evolution have gone further beyond microbes, beyond animals, perhaps even to intelligence? Because then, something terrible happened. The paradise died. Slowly at first, then all at once. A runaway greenhouse effect, triggered by unrelenting volcanic outgassing, began its march. Surface temperatures crept upward, oceans evaporated, and the very vapor that once nurtured life became a deadly trap. In the upper atmosphere, solar radiation shattered water molecules, and light hydrogen escaped into space, leaving behind oxygen that reacted with surface rocks. The seas boiled into nothingness. Venus, the twin of Earth, suffocated in its own heat. But here lies the terrifying question. If there had been an intelligent species on Venus, did they see it coming? Imagine a civilization watching their blue world wither under an intensifying sun. Would they have tried planetary-scale geoengineering, reflective mirrors in orbit, vast carbon scrubbers, attempts to migrate into space? Perhaps they built technologies beyond our comprehension, efforts to rewrite the fate of a dying world. If so, what traces of them might remain, locked under the planet's young volcanic surface, which geologists believe was completely resurfaced about 500 million years ago? Unusual mineral deposits, geometric anomalies hidden beneath the crust, silent artifacts of a species lost to time. We have only glimpsed hints. The Soviet Venera landers of the 1970s and 1980s, the only machines to survive Venus's furnace-like surface, transmitted photographs of endless plains scattered with volcanic rock before succumbing to crushing heat and pressure within 2 hours. Radar mapping by later missions has uncovered puzzling surface structures, formations that do not easily align with known geological processes. Are they simply misunderstood volcanism, or something else? If Venus truly hosted civilizations, their silence now serves as a cosmic warning. Even intelligence, even technology may be powerless against planetary collapse. Venus stands as a tombstone in our solar system, etched not with words, but with sulfur clouds and stone melted by fire. And while Venus burned, Earth itself was entering its own deadly trial. 2.4 billion years ago, our home planet suffocated under what scientists call the Great Oxidation Event. Oxygen, the very gas that allows us to breathe, became a deadly poison. Entire kingdoms of life choked and vanished. What we call the foundation of existence was once an apocalypse. Before this upheaval, Earth's atmosphere was nearly devoid of oxygen. Its oceans teemed with microbial life, anaerobic bacteria that thrived in chemical soups rich with dissolved iron and sulfur. These organisms fed on sunlight, chemical reactions, even radioactive decay. Life was strange, alien, and flourishing. Then came the cyanobacteria. They evolved photosynthesis, harnessing sunlight not just for survival, but to release oxygen as waste. To them, oxygen was nothing more than chemical trash. But for nearly every other creature on Earth, it was lethal. Oxygen corroded cell structures, destabilized metabolisms, and triggered catastrophic die-offs. Over hundreds of millions of years, oxygen seeped into the atmosphere, slowly but relentlessly. Oceans turned rusty red as iron oxidized into massive deposits, the very banded iron formations we mine today. Methane, the greenhouse gas that had kept Earth warm, was oxidized away, plunging the planet into severe ice ages. It was mass extinction on a scale almost beyond imagination. Yet not all perished. Some organisms retreated underground, hiding in oxygen-free pockets of Earth. Others adapted, developing intricate biochemical defenses against the toxic gas. And then, a few organisms made the most radical leap in Earth's history. They learned to use oxygen itself as fuel. This discovery unlocked far more energy than anaerobic life could ever access. These survivors became the ancestors of every complex form of life, including us. But consider this chilling possibility. What if survival required not just biology, but technology? Even today, bacteria display astonishing engineering skills. Magnetotactic bacteria build microscopic compasses out of magnetite crystals. Others construct intricate mineral scaffolds with precision rivaling human nanotechnology. If simple microbes are capable of such feats, what might intelligent anaerobes have created under the shadow of extinction? Could early Earth have seen primitive technologies long before the rise of animals? Devices or adaptations designed not of stone and fire, but of chemistry and mineral manipulation? The Great Oxidation Event was not just a biological revolution. It may have been the first silent test of intelligence on Earth, and perhaps its first lost civilization. Imagine this: microscopic civilizations that we've long dismissed as simple bacteria may have once organized themselves like vast biological computer networks, humming with collective intelligence. Biofilm-forming bacteria are not just slimy coatings on rocks or teeth. They communicate through chemical signals. Across sprawling colonies, coordinating behaviors in ways that eerily resemble primitive information systems. What if, billions of years ago, those ancient organisms, facing extinction-level threats, developed something astonishing: collective survival strategies that bordered on technological solutions? Picture this: as Earth's atmosphere filled with rising oxygen, a substance that was not life-giving but poisonous to these early species, survival may have demanded desperate innovation. Imagine coordinated construction of vast underground refuge systems, microbial cities hidden from the toxic skies. Think of selective breeding programs, ancient organisms accelerating their own evolution, producing strains more tolerant to oxygen's deadly effects. And what if they experimented with primitive metallurgy, crafting protective compounds or mineralized barriers to shield themselves from oxidative destruction? The fossil record from this era leaves us with frustrating gaps. Most life was microscopic, soft-bodied, and nearly impossible to preserve. Yet in scattered places, nature gives us cryptic hints. Towering stromatolite reefs, built layer by bacterial colonies, rise out of ancient stone like monuments from another world. These structures were not merely accidents of growth. They appear to represent coordinated construction on a massive scale, larger and more complex than anything typical bacterial mats should have produced. Geology adds to the mystery. Rock layers from the Great Oxidation Event carry isotope signatures that scientists still struggle to explain. Carbon ratios display unusual patterns that don't align with random natural processes. Instead, they suggest something controlled, massive, organic matter decomposition within confined environments, almost as if waste management systems or primitive agricultural practices had been at play. Could these chemical fingerprints be the residue of an early experimental form of biological engineering? The survivors of this ancient apocalypse eventually paved the way for all complex life on Earth. Yet survival may not have been blind chance. It might have required collective intelligence, coordination, and technological capabilities that we are only beginning to glimpse through these faint traces. And the haunting question is this: were they the first intelligent species to face planet-wide catastrophe, or simply the first to survive it? Their triumph holds eerie lessons for us, as humanity stands today at the edge of its own environmental crisis. The shadow of that first great dying looms over us. If early Earth's organisms adapted through more than biology, through foresight, engineering, or even technology, then the blueprint of survival may already be written into Earth's deep past. And then, just as the planet seemed stabilized, something extraordinary happened. 540 million years ago, life erupted in a storm of complexity. Almost overnight in geological terms, the oceans filled with predators, prey, and creatures with sophisticated sensory systems that seemed engineered rather than stumbled into existence. This epoch is known as the Cambrian explosion, a burst of innovation so sudden, so complete, that evolutionary theory still strains to explain it. Before the Cambrian, Earth was eerily quiet. For billions of years, life clung to simplicity. Bacteria, primitive algae, and sluggish multicellular organisms that drifted without purpose. The fossil record shows only the faintest of changes, as though evolution had hit pause. Then, without warning, the oceans awakened with predators bearing eyes sharper than modern insects, creatures armed with hydraulic claws, and bizarre anatomies that looked less like natural progressions and more like the sketches of some hidden architect. Consider the trilobite. Its eyes were made of calcite crystals, aligned with mathematical precision to create compound vision, capable of tracking motion with stunning clarity. This is not a feature evolution should have whipped together in a few million years. Modern arthropods took far longer to refine their visual systems. The trilobites' perfect lenses suggest something closer to engineering than blind trial and error. Or the fearsome Anomalocaris, a predator of nightmares. Its flexible, grasping arms functioned like hydraulic capture devices, its circular mouth bristling with plates designed to crush armored prey. Its body plan seemed to borrow elements from multiple future animal groups, a strange biological collage that would never be repeated. Was this random mutation or deliberate assembly? Even stranger was hallucigenia, an almost alien creature, walking on rows of spiny legs, its back lined with sharp defensive spikes. Its anatomy was bizarre but purposeful, requiring tight coordination between organ systems. The odds of such a precisely balanced design arising by accident are vanishingly small, and then come the real riddles. Organisms that evolved features with no clear purpose in their environment. Some developed sensory organs tuned to detect chemicals that were virtually absent from Cambrian seas. Others sprouted defensive adaptations against predators that did not yet exist. These premature anticipatory features imply a kind of directed evolution, adaptations aimed not at present threats but at future ones. Natural selection, as we know it, cannot predict the future. So who or what was guiding them? Modern genetics deepens the enigma. The Cambrian period saw the simultaneous appearance of most major animal body plans and the genetic toolkits required to build them. The Hox genes, master regulators that dictate the architecture of bodies, brains, and limbs, appear to have undergone rapid, coordinated changes during this brief window. How could multiple genetic systems, each regulating hundreds of downstream processes, all transform together without catastrophic collapse? To some, it suggests external intervention, perhaps a form of ancient genetic engineering. Some scientists have proposed horizontal gene transfer as a mechanism, where organisms exchanged genetic innovations the way bacteria trade DNA today. But such exchanges would require molecular machinery capable of integrating complex genetic blueprints without destroying the host, a system far more sophisticated than anything random evolution is known to produce. Others fall back on environmental explanations, rising oxygen levels, shifts in ocean chemistry, or predator-prey arms, races driving rapid change. Yet even these pressures cannot account for the sheer speed, precision, and foresight embedded in Cambrian organisms, which leaves us with a haunting possibility. The Cambrian explosion may not have been a natural evolutionary spasm at all, but the first great biological engineering project on Earth. Imagine for a moment that evolution is not a slow, grinding wheel, but a lever, one that can be pushed suddenly, violently, and with deliberate force. The Cambrian explosion, some 541 million years ago, wasn't merely a burst of life. It was a biological detonation. In a geological instant, single-celled simplicity gave way to trilobites with armored shells, predators with grasping claws, and creatures with eyes that could pierce the darkness of ancient seas. Some biologists argue this leap was guided by evolutionary pressures, but others whisper a more haunting question. What if this acceleration was directed? Could intelligence, whether from within evolving organisms or from an external source beyond our comprehension, have nudged life forward? If so, then the architects of the Cambrian explosion left more than fossils. They left their signature coded into the genes of every living being, and in the rocks themselves, relics emerge, relics that tell impossible stories. For nearly 2 centuries, scattered discoveries have suggested that manufactured objects, out-of-place artifacts, lie buried in geological layers where they simply shouldn't exist. Mainstream science labels them hoaxes, accidents, or misidentifications, yet some cases refuse to die. In 1844, Sir David Brewster, an eminent Scottish physicist and founder of modern optics, reported something staggering: a metal nail encased in sandstone from a quarry near Glasgow. Geological analysis placed the rock's age at nearly 400 million years, long before the first trees, long before vertebrates crawled onto land. When tested, the nail's composition showed traces of nickel, an element commonly used in metallurgy to harden iron, but completely unnecessary and unexplained in natural ore formations. Other claims soon followed. A delicate gold chain entombed in coal deposits dated to 300 million years ago. A bell-shaped metal vessel blasted from solid rock in Massachusetts. And the most perplexing of all, the mysterious spheres of Klerksdorp, perfectly shaped metallic orbs extracted from South African Precambrian formations over 2.8 billion years old. Some spheres appear to have etched grooves running around their circumference, geometry nature has no need for. Skeptics are quick to answer: contamination, fractures in stone, mineral lookalikes, or outright fraud. And in truth, most supposed anomalies fall apart under scrutiny. Coal seams can be infiltrated by modern debris. Crystals can mimic the appearance of worked objects. Human imagination can misinterpret random shapes as deliberate design, but not all. One artifact in particular has resisted dismissal for over a century: the Wolfsegg iron. Unearthed in 1885 from a coal seam near Vöcklabruck, Austria. Perfectly. Cube-like with sharp edges and deep grooves carved into its sides, the object was embedded in brown coal dated to 20 million years ago. Multiple independent analyses were conducted: X-ray scans, chemical testing, microscopic inspections. Every test converged on one chilling fact: this was no natural stone. The alloy contained iron fused with trace elements in ratios unknown to geology, but consistent with metallurgy. Its structure suggested it had been cast or machined. Even stranger carbon dating of the surrounding coal confirmed the deposit's ancient age. If genuine, this single object would rewrite everything we think we know about civilization's timeline. The Wolfsegg iron echoes the lesson of another enigma: the Antikythera mechanism. Discovered in 1901 in a shipwreck off Greece, this corroded bronze device looked like a lump of metal until X-ray imaging revealed its inner workings. A clockwork computer with interlocking gears so precise that nothing comparable appeared again until medieval Europe, 1,500 years later. If the Greeks could calculate eclipses with gear-driven technology 2,000 years ago, what might unknown civilizations have achieved in the deep prehistory of Earth? Here lies the paradox. Fossils survive only in rare conditions. Bones dissolve. Flesh vanishes. Civilizations crumble. If ancient technologies once flourished, the chances of them surviving deep time are vanishingly small. Even modern human relics are fragile. Visit the ruins of abandoned factories and you'll find rust eating through steel beams in mere decades. Electronic circuits corrode into dust. Skyscrapers would collapse into rubble within centuries if left untended. And yet, certain materials can endure geological time. Metallic glass resists corrosion. Advanced ceramics can remain intact for millions of years. Crystalline structures preserve microscopic detail that outlasts even continental shifts. This means the absence of overwhelming evidence doesn't prove non-existence. It merely proves how brutal time is. We may be looking in the wrong way with tools designed to detect pottery shards and stone axes, while ignoring what alien or pre-human technologies might have looked like after eons of chemical and tectonic transformation. But then comes the mathematical dagger. If advanced civilizations once thrived, why don't we see their echo in the stars? Here, the Drake equation enters, a formula proposed in 1961 by astronomer Frank Drake to estimate the number of detectable civilizations in the Milky Way. At first glance, the math seems optimistic. The galaxy births about 7 new stars per year. Nearly every star, thanks to discoveries from missions like Kepler, hosts planets. Many of those planets orbit in the habitable zone, where water can exist. Early calculations suggested millions of Earth-like worlds waiting for life to flourish. But as the factors narrow, hope evaporates. The probability of life actually beginning, of chemistry becoming biology, remains the greatest unknown. Despite decades of experiments recreating early Earth conditions, we have not coaxed a single self-replicating system into existence. Then, even if microbes form, the leap to complex cells, the kind with nuclei, mitochondria, and machinery capable of complexity, appears staggeringly rare. On Earth, it took 2 billion years for this transition to occur. 2 billion years of still oceans and bacterial mats before complexity finally arrived. That delay suggests an evolutionary bottleneck so severe that most worlds may never escape microbial stagnation. And so, when the numbers are multiplied, when we plug cautious, evidence-based values into the Drake equation, we arrive not at a galaxy buzzing with neighbors, but at a sobering possibility. We may be alone. Not just in our star system, not just in our galaxy, but in the observable universe itself. Intelligence itself may be the most unforgiving bottleneck in the story of life. For hundreds of millions of years, Earth has been a grand laboratory of evolution, producing creatures of unimaginable diversity. Insects with compound eyes sharper than cameras, cephalopods with skin that can change color in milliseconds, and birds that navigate entire hemispheres guided only by the magnetic whispers of the planet. And yet, out of all these evolutionary miracles, only one fragile lineage, our own, stumbled upon the ability to build machines, split atoms, and send whispers of its existence into the stars. What if the spark that ignites science and technology is not just rare, but vanishingly improbable? Imagine a universe filled with lush forests, coral seas, and alien predators, yet utterly silent, because the intelligence required to question the stars simply never arises. But even when intelligence emerges, another question shadows its triumph. How long can it last? Civilization longevity is perhaps the most terrifying parameter of the Drake equation. If most technological societies burn bright only for a few centuries before extinguishing themselves, then the cosmos could be strewn with ruins of failed civilizations, ghost cities orbiting dead suns, silent monuments to species that reached for the stars only to collapse before their signal ever crossed the void. Recent attempts to ground these probabilities in numbers have produced sobering results. When astronomers apply conservative values to the Drake equation, the outlook turns bleak. Some models predict fewer than one technological civilization per galaxy at any given time. Others are even harsher. Civilizations might be separated not just by stars, but by millions of galaxies and billions of years. This is the nightmare at the heart of the Fermi paradox. If intelligent life is supposed to be common, then where is everybody? In 1950, over lunch at Los Alamos, physicist Enrico Fermi famously asked this disarming question. It still keeps scientists awake at night. The universe should be teeming. with voices. Our galaxy alone hosts more than 400 billion stars, most with planetary systems. Billions of those worlds orbit within habitable zones where liquid water, the foundation of life as we know it, could exist. And then comes the cruel twist. Time itself multiplies the odds. The Milky Way has been around for over 10 billion years. Civilizations older than ours could have had millions, even billions of years to rise, master technology, and spread across the stars. At even modest speeds, self-replicating probes or colonizing fleets could have reached every star system in the galaxy within a few million years, a blink in cosmic time. So why do our radio telescopes hear nothing but cosmic static? Projects like SETI have swept across millions of star systems, scanning thousands of frequencies, listening for a single artificial whisper. None have come. Optical searches look for interstellar laser beacons. Infrared surveys search for waste heat that a galactic-scale civilization, one capable of constructing Dyson spheres around entire stars, could never hide. The silence holds, and yet Earth itself leaks signals like a beacon. Our radio and television broadcasts have already formed an expanding bubble stretching more than 100 light-years into space. Nuclear tests leave signatures of gamma radiation visible from afar. Industrial pollution alters our atmosphere in ways advanced telescopes could detect. Even if we tried to stay hidden, the colossal waste heat of energy consumption and the glow of megastructures would betray us. The paradox deepens. Why can't we see them if we ourselves are so visible? One unsettling answer is the Great Filter hypothesis. The idea that somewhere along the chain from microbial life to star-faring civilization lies a deadly barrier that few, if any, can pass. The filter might be behind us, in which case, humanity is unimaginably rare, one of the few species to ever make it this far. Or it lies ahead, meaning our future holds the same self-destruction that silenced countless others before us. Even more disturbing possibilities whisper from the edge of theory. Perhaps civilizations survive, but they transcend reality itself, uploading their minds into digital realms or collapsing into microscopic computing substrates invisible to our telescopes. Maybe they've discovered ways to escape the observable universe altogether, leaving us stranded in a silent cosmos. In 2018, researcher Anders Sandberg and colleagues applied advanced Bayesian statistics to the Drake equation. Their results shocked the scientific community. The probability of another civilization existing in our galaxy today might be less than 1 in 10 billion. In our local galactic cluster, the probability drops to nearly 0. These results do not prove we are alone, but they paint a haunting picture. Cosmic loneliness isn't the exception, it's the most likely outcome. If that's true, then humanity's survival carries unimaginable weight. Our extinction would not simply erase our species. It could erase the only consciousness in the observable universe capable of wondering, dreaming, and appreciating the grand tapestry of creation. And yet, within this bleak mathematics lies hope. If intelligence is that rare, then every heartbeat, every ecosystem, every moment of awareness on Earth is infinitely precious. Our search for extraterrestrials may one day succeed. But if it does not, then the truth may be even more staggering. We are the universe's only chance to know itself. The silence of the universe is haunting. For decades, scientists have pointed radio telescopes at the stars, straining to hear even the faintest whisper of another intelligence. Yet nothing answers back. But what if this silence isn't proof that we're alone, but evidence that Every civilization faces deadly evolutionary bottlenecks, hurdles so catastrophic that few, if any, survive long enough to call out into the void. And here's the chilling thought. What if Earth has already seen civilizations rise and fall long before us? What if their remains are not scattered across the stars, but hidden in the darkest, most inaccessible places on our own planet? 7. Miles down, at the bottom of Earth's deepest ocean trenches, sunlight has never pierced the water. Pressure here is so immense it would crush a nuclear submarine like an empty soda can. It is a world more alien than Mars. Yet when sonar maps these abyssal plains, they sometimes reveal shapes that should not exist. Perfect rectangles, geometric patterns, circular structures stretching for miles in diameter, aligned with precision that nature rarely produces. The Mariana Trench, Earth's deepest wound, plunges over 36,000 feet below sea level. Recent high-resolution mapping has revealed anomalies so bizarre that some scientists whisper they look more like the ghostly outlines of cities than the chaos of geology. Straight lines that run for miles, rectangular formations with right angles, so sharp they resemble foundations. Vast circular depressions arranged in a grid, as if mimicking the urban planning of some long-forgotten people. The mystery deepens. Geology tells us that ocean floors are constantly destroyed and renewed by tectonic forces. No surface structure should survive more than 200 million years. Yet, sediment analysis and magnetic signatures from certain trench regions suggest some. Formations may be much older. How could such features persist if the seafloor itself should have been recycled? The answer may lie in rapid burial. Cascades of sediment and underwater landslides can entomb structures in mud thousands of feet thick, turning them into time capsules, preserved beyond imagination. And it's not only the trenches. In some areas, underwater mountain ranges bear scars that indicate they once stood above sea level. Ancient landscapes drowned by rising oceans and shifting continents. If civilizations once flourished there, their cities would now lie miles beneath the waves. Technology is beginning to catch glimpses of these secrets. Advanced sonar and 3D imaging reveal interior chambers, tunnels, and strange architectural shapes hidden within rocky formations. Some even bear markings that look carved rather than fractured. One of the most controversial examples lies in the Bahamas, the Bimini Road. To some, it is a natural formation of fractured limestone, but to others, the precisely cut rectangular blocks, some bearing what appear to be tool marks, are evidence of deliberate construction by an unknown people thousands of years ago. The mystery doesn't stop with stone. Deep-sea drilling projects have pulled up metallic fragments, strange mineral concentrations, and organic compounds that don't match known biology. Could these be remnants of technologies or life forms that predate our history? And life itself in the deep oceans defies expectations. Around hydrothermal vents, where scalding water rich with chemicals spews from the crust, thrives entire ecosystems. Giant tube worms, ghostly crabs, and bizarre fish survive without sunlight, drawing energy from chemistry instead of photosynthesis. These alien-like colonies demonstrate that advanced life can evolve in extreme conditions. Some of these communities show surprising organization, patterns that go beyond what simple chemistry should allow. In fact, the preservation potential of the deep ocean far exceeds the land. Cold temperatures, low oxygen, constant darkness, protection from weather and erosion. Artifacts that would crumble on land could endure here for millions of years, intact beneath sediment and ice. And yet, despite these tantalizing clues, our exploration of the deep sea remains painfully limited. Robotic submersibles can only stay in the trench depths for hours. Each mission covers just a few square miles, while Earth's deep oceans stretch across millions. We have mapped Mars in greater detail than our own sea floor. The odds of stumbling across artificial structures by chance are vanishingly small. But imagine if we searched with intent. Artificial intelligence scanning sonar data for unnatural patterns. Drilling rigs delicately sampling suspected structures. Submersibles targeting the anomalies no one has dared to explore. The deep ocean may not just be Earth's last frontier. It may be the graveyard of civilizations older than our own. And if the oceans hide secrets, what about the ice? Beneath Antarctica's frozen shell, ice over 2 miles thick, locked in place for millions of years, satellite imaging has revealed something extraordinary. Straight lines extending for dozens of miles, vast circles spanning several kilometers, rectangular blocks aligned in grids. These patterns lie buried in solid ice, protected from erosion, preserved as though frozen in time. Antarctica was not always the desolate wasteland we know today. 50 million years ago, it was a green continent, teeming with palm trees, vast. Rivers and ecosystems that rivaled modern rainforests. Fossils and coal beds prove it once thrived with life. In that temperate age, Antarctica could easily have hosted civilizations, isolated from the rest of the world, allowed to evolve in secrecy. And there's more. Ice cores drilled from deep within the continent contain anomalies, metallic fragments, unknown organic compounds and mineral concentrations that don't match Antarctic geology. These are not random impurities. They hint at something buried far deeper. Lake Vostok, sealed beneath 2 miles of ice for millions of years, is one of the most mysterious places on Earth. A liquid lake, isolated from the surface since before humans evolved. Whatever lives, or once lived, there is unlike anything we know. Scientists probing its waters have already discovered unusual microbial DNA. But what if Lake Vostok conceals more than microbes? What if beneath that dark alien water lies evidence of something far more advanced, frozen, waiting to be discovered? Beneath Antarctica's frozen wastelands, scientists drilled into one of the most isolated environments on Earth, Lake Vostok, a body of water sealed beneath more than 2 miles of ice for at least 15 million years. When the first samples were retrieved, the results were nothing short of astonishing. Hidden within this black, pressurized abyss, researchers discovered microbial life unlike anything cataloged before. Genetic signatures that don't correspond to known organisms. It was as if evolution had followed a separate path in total secrecy, creating an ecosystem untouched since long before humanity walked the Earth. But biology wasn't the only enigma. Satellite imagery of the region around Lake Vostok revealed geometric patterns that defied natural explanation. The lake's shoreline wasn't the smooth, irregular curve geologists expect, but instead included straight segments and sharp angular corners. To some, this suggested natural fracturing or unusual glacial stress. To others, the clean geometry whispered of something far more deliberate, the possibility that beneath Antarctica's ice lie structures, not formations. The mystery deepened when researchers compared this with one of history's strangest documents, the Peary Race Map of 1513. Drawn by an Ottoman admiral using sources he claimed were ancient maps, it depicted the coast of Antarctica in startling detail. Without ice cover. What makes this impossible is that Antarctica wasn't officially discovered until 1820, 3 centuries later, and even modern cartographers couldn't confirm the subglacial topography until the age of satellites. Could the Peary Race Map be Evidence of lost knowledge from a civilization that mapped the world long before recorded history? Or was it simply an astonishing coincidence? Modern ice-penetrating radar added more fuel to the fire. Beneath the ice sheets, researchers detected cavities, tunnels, and chamber-like hollows. While glaciologists argued these were the results of water movement and ice dynamics, some of the formations displayed mathematical regularity. Grids, angles, and alignments nature rarely produces. Were these natural wonders sculpted by physics, or relics of an advanced society erased by time and buried under eternal ice? And now the clock is ticking. Climate change is accelerating the collapse of Antarctica's frozen shield. On one hand, this retreat might reveal landscapes and secrets hidden since before the last ice age. On the other, fragile evidence, if it exists, could be destroyed before anyone has a chance to study it. International treaties strictly control Antarctic exploration, prioritizing biological and climate science while banning archaeological digs that could probe these mysteries directly. Private expeditions face even harsher obstacles: astronomical costs, political restrictions, and the sheer brutality of Antarctic weather. As global temperatures rise, humanity might soon be confronted with secrets from a world it is unprepared to face. But Antarctica is not Earth's only time capsule. If our planet hides its history beneath ice and oceans, the moon may hold it, in plain sight. Unlike Earth, where wind, water, and shifting tectonic plates erase evidence within millions of years, the moon is airless, weatherless, and geologically dead. It preserves history for billions of years. The footprints left by Apollo astronauts in the late 1960s still sit undisturbed, as crisp as the day they were pressed into the dust. And here's where things become truly extraordinary. When Earth suffers a massive asteroid strike, debris from our planet is blasted into space, some of it traveling far enough to land on the moon. Scientists estimate that over billions of years, millions of tons of Earth rock have accumulated across the lunar surface. This means the moon is a library of Earth's past. Locked inside lunar soil could be fossilized organisms, chemical traces of ancient oceans, even fragments of lost civilizations, if such civilizations ever existed before our own. This isn't speculation without evidence. Analysis of Apollo rock samples revealed fragments with isotopic compositions identical to Earth's mantle, proof that terrestrial material rests on the moon. And because the lunar surface doesn't erode, any artifact, organic molecule, or manufactured object delivered there could remain perfectly preserved for eons. The discovery of water ice in permanently shadowed craters only strengthens this possibility. Volatile materials can survive there for millions of years. High-resolution orbital imagery has only added to the intrigue. Among countless craters and lava plains, researchers have identified geometric features, linear ridges, and right angles that don't align with expected natural processes. While most are likely products of geology, some remain unexplained. The far side of the moon, hidden from Earth, is particularly tantalizing. It is the most ancient, least disturbed surface in the solar system, and the best place to search for Earth's lost history. China's Chang'e missions have begun exploring this side, but so far only in limited areas. Consider this. The Apollo astronauts collected less than 9 pounds of lunar rock, all from 6 small patches on the near side. That's a microscopic sample of an entire world. Statistically, the chance of stumbling upon ancient terrestrial artifacts with such a limited grab is near zero. To uncover them, we would need permanent lunar bases, drilling technology, and systematic surveys. tools that are only now becoming possible as space agencies and private companies plan lunar mining and colonization. Ironically, it might not be government science missions but commercial excavations that uncover Earth's forgotten past. But there is a danger. International space law doesn't yet address the protection of archaeological evidence beyond Earth. If miners or corporations stumble upon something extraordinary, say a fragment of ancient technology embedded in lunar rock, nothing would stop them from destroying it in the rush for profit. The moon may be humanity's greatest untapped archaeological treasure, but like Antarctica, its secrets hang in a fragile balance between discovery and obliteration. For 4 billion years, the moon has stood as Earth's silent witness, a timeless archivist, guarding in its dust and rock a memory older than life itself. Every impact crater, every grain of regolith is a page in a cosmic diary. Unlike Earth, which erases its past with terrifying efficiency, the moon remembers everything. It carries secrets that may one day shatter our understanding of history, waiting for the right missions to finally unlock what it has seen. Earth, by contrast, is a destroyer. Our planet operates like the most ruthless recycling plant in the universe, systematically shredding every trace of its own past. Mountains are ground into dust. Oceans swallow entire coastlines. Volcanoes smother landscapes in fire. Given enough time, even the grandest cities would be reduced to nothing, not even a whisper in the fossil record. And that means one haunting possibility. Entire civilizations could have risen and vanished long before us, leaving not a single trace. The greatest culprit is tectonic power, the restless motion of continents drifting across the planet's surface. These plates crawl only inches per year, but over millions of years they collide, crumple, and crush everything above them. Whole coastlines sink into the mantle, obliterated in magma. Ancient seafloors vanish forever at subduction zones. Even now, the oldest ocean floor is just 200 million years old, a mere blink compared to Earth's age. That means if an advanced coastal civilization had once thrived hundreds of millions of years ago, its ruins would have been fed into the furnace of the planet, erased so completely that no trace could ever resurface. But tectonics is only one blade of the executioner's axe. Erosion works more patiently, yet just as mercilessly. Wind, rain, and chemical weathering grind down even humanity's mightiest works. The Egyptian pyramids, only 4,000 years old, already show heavy scars of erosion. Now imagine a monument, even larger, standing for 4 million years. It would not stand at all. It would be dust, indistinguishable from the desert that once held it. Entire mountain ranges that once rivaled the Himalayas have been worn to gentle rolling hills, erased by nothing more exotic than time and weather. Rivers, too, become accomplices in this erasure. They carry mountains grain by grain into the sea, where vast sedimentary layers bury the surface world. Thousands of feet of rock slowly entomb whatever once stood there. Entire cities, landscapes, and civilizations crushed into anonymity beneath the weight of geological time. And then there are the glaciers, colossal engines of destruction. During ice ages, continental ice sheets up to 2 miles thick plowed across North America and Europe like bulldozers of ice, scraping the surface bare and grinding everything beneath into powder. Structures, monuments, or even cities would have stood no chance beneath their frozen advance. Volcanoes, meanwhile, act as Earth's sudden assassins. In places like the Siberian Traps or the Deccan Plateau, eruptions blanketed regions the size of countries with thousands of feet of lava. Any Evidence of a civilization caught beneath would now lie encased in solid basalt, altered beyond recognition. Add in the corrosive bite of chemical weathering, metals rusting to dust, ceramics breaking down, concrete dissolving, and even our most permanent materials reveal themselves as temporary. Even life itself joins the conspiracy. Roots crack through stone. Microbes feast on organic remains. Forests reclaim abandoned ruins in decades. If left alone, even our skyscrapers would vanish under vines, soil, and eventually stone. And then there is time, the ultimate destroyer. Processes that seem slow to us become cataclysmic over geological scales. Freeze-thaw cycles split rock into rubble. Rising seas drown coastlines again and again. Temperature shifts accelerate. Erosion. Over millions of years, nothing stands unchallenged. Think of this staggering scale. Human civilization, from our first farmers to today's digital age, spans barely 10,000 years. The Industrial Revolution? Just 200. That is less than 0.002% of the time since complex life appeared. If Earth's 4.5 billion year history were compressed into a single year, all of humanity's story would play out in the final seconds before midnight on December 31st. The rest of the calendar? Silent, unrecorded, yet possibly filled with lost chapters no one has ever read. So ask yourself this. What if we are not the first? What if civilizations just like ours, or far greater, once rose and fell, their traces erased by Earth's relentless geology? What if we are living on a planet that has already forgotten its previous storytellers? Because the truth is chilling. On geological timescales, even our most durable creations will be erased. Wood rots within centuries. Iron rusts within millennia. Stone crumbles within millions of years. Fossilization itself is rare, a fluke requiring perfect conditions. Most species leave no trace at all. And if life struggles to be remembered in stone, what chance does technology have? The odds are terrifyingly clear. The fossil record is biased, broken, and brutally incomplete. And if we apply the same rules to technology, then the story of ancient intelligence may already lie lost beneath our feet, deleted by time itself. Imagine walking through a modern landfill 100,000 years from now. Plastics, metals, microchips, everything that defined our era would be little more than dust or corroded fragments. This is the hidden tragedy of time. Most of what we build, no matter how advanced, is never meant to last across geological ages. Plastics, which today choke our oceans and pile up in mountains of waste, aren't eternal. They break down through the relentless assault of sunlight, what scientists call photolysis, and through the slow but inevitable work of bacteria that find ways to digest synthetic polymers. Electronics, with their delicate copper wiring and soldered circuits, corrode once moisture and oxygen seep in. Even the most sophisticated machines, spacecraft engines, nuclear reactors, particle accelerators, are fragile when measured against the clock of deep time. Their parts, made of dissimilar metals, polymers, and ceramics, decay at different rates. Within a few millennia, most would be unrecognizable rubble. And here lies the core dilemma. Even if an advanced civilization existed millions of years ago, what would its remains look like today? Archaeologists, trained to recognize human-made artifacts, stone tools, pottery shards, architectural ruins, are bound by their own expectations. But an intelligence that evolved millions of years before us might have chosen completely different paths of technology. Their tools might not resemble ours at all. Their machines might not use metals or wires. Their buildings might not be built from stone, wood, or steel? What if their entire material culture was something we would dismiss as natural formations? This raises a haunting question. How would we even know if we were standing on the ruins of an ancient, non-human civilization? The problem grows deeper when mathematics enters the equation. Consider this: modern human civilization has been technological for perhaps 10,000 years, a blink in Earth's 4.5 billion year history. If another intelligent species had its own 10,000-year window, randomly scattered across those vast eons, the odds of its traces surviving and being found become vanishingly small. Current archaeological surveys, even with satellite imaging, ground-penetrating radar, and LiDAR scans, cover only the tiniest fraction of Earth's crust. Most excavations focus on known human sites, Egypt, Mesopotamia, Mesoamerica, rather than searching for anomalies that might belong to non-human intelligence. Even when something unusual is unearthed, the challenge of dating magnifies the problem. Radiometric methods, powerful though they are, often carry uncertainties of millions of years at the scales required for deep time. An artifact that survived for 50 million years could easily be mistaken for a peculiar mineral deposit, a strangely geometric crystal, or a natural rock formation. In fact, some geological oddities we already know, perfectly spherical hematite concretions, cube-like pyrite crystals, might be indistinguishable from artificial artifacts unless analyzed under the finest microscopes. But suppose for a moment that something did survive. What materials would stand the test of time? The answer is both fascinating and chilling. Diamonds top the list. These crystalline forms of carbon laugh in the face of chemical weathering and remain stable under crushing pressure for billions of years. Industrial diamonds, used in drills, lasers, and cutting tools, could theoretically outlast continents. Unless destroyed by temperatures above 3,000 degrees, 1650 Dixie, diamonds endure. Then there are advanced ceramics, silicon carbide, titanium, carbide, zirconium oxide. Unlike metals, they resist corrosion, radiation, and even acids. Protected from abrasion, such ceramics could survive millions of years, long after steel skyscrapers and bronze statues have vanished. Another contender is the strange class of metallic glasses, alloys cooled so quickly they never form crystals. Their amorphous structure makes them uniquely resistant to corrosion. Unlike iron or copper, which crumble into oxides and patinas, metallic glasses could sit buried in the earth for unimaginable spans of time without losing their shape. And what of plastics? Ordinary ones rot away within centuries. But ultra-high molecular weight polyethylene and perfluorinated polymers, designed for extreme industrial use, might survive tens of millions of years if entombed in the right conditions. We already know Teflon-like substances resist nearly everything. Imagine a tool or device made from such material lying forgotten in a deep sedimentary bed. Crystalline minerals like quartz provide another eerie possibility. A quartz carving could last hundreds of millions of years. The catch? Over such spans, it might come to resemble a natural crystal. Only under microscopic inspection would human-like patterns, straight edges, polished surfaces, geometric symmetry betray their artificial origins. The most futuristic survivors might be composite materials, carbon fiber fused with ceramics, or metal matrix composites designed for spacecraft. Their layered engineered structures combine durability with resilience. Such materials could remain recognizable far into the future, even under geological stress. And then there is nanotechnology. Imagine molecular-scale machines, carbon nanotubes. diamond-like coatings, nanoscale lattices that resist heat, pressure, and radiation indefinitely. A civilization millions of years old might have left behind artifacts invisible to the naked eye, but eternal at the microscopic level. Yet even the strongest material is nothing without the right environment. Time is merciless, and Earth is restless. Plate tectonics crush continents. Volcanoes melt rock. Glaciers grind landscapes to dust. Oceans corrode and recycle the seabed. For something to endure millions of years, it must be hidden where Earth's violence cannot reach. Deep underground lies the best hope. Caves, salt beds, and sedimentary layers provide relative stability, sheltering artifacts from oxygen, water, and temperature shifts. The deserts offer another refuge, dry climates that minimize decay. Polar ice, though not eternal, could preserve materials for millions of years in frozen stasis. Even volcanic eruptions, destructive in the moment, can entomb artifacts beneath protective layers of ash and lava, sealing them away like a time capsule. And then, perhaps most intriguingly, there are the deep oceans. While shallow seas teem with life that corrodes and consumes, the abyssal plains, miles beneath the surface, are stable, cold, and quiet. Artifacts resting there might last far longer than on land. So the question lingers like a shadow. If ancient civilizations once walked this earth, is it possible that their last surviving traces, diamonds, ceramics, nanostructures, are buried deep below our feet, waiting to be found? Imagine, for just a moment, that an ancient civilization once stood on Earth, millions of years before us, and knew their time was running out. If they wanted their memory to survive not just centuries, not even millennia, but geological time itself, what choices would they make? The key insight is chilling. Perhaps they deliberately designed their most sacred artifacts for endurance, not beauty. They may have crafted them from materials so resilient that even after mountains eroded, oceans shifted, and continents broke apart, their legacy would still whisper to those who came after. Instead of fragile scrolls, crumbling statues, or wooden relics, imagine monuments built from granite, quartz, obsidian, or even alloys designed to resist decay. Imagine messages etched not on paper, but on metals that corrode only after eons. These weren't just relics, they were time capsules. To find them, our archaeological lens must change. Rather than searching for pottery shards in ordinary sites, we should be asking what materials could endure millions of years, and where would an intelligent species hide something they desperately wanted future eyes to see? This raises a deeper question. Did they understand geological timescales better than we do? If they did, they may have known where tectonic stability offered the greatest chance of preservation. Ancient desert plateaus, vast caves, or under layers of basalt that shielded treasures from erosion and plate movement. Perhaps we've been looking in the wrong places all along. But even the most durable materials face obliteration eventually. Erosion, subduction, and cosmic bombardments erase almost everything. Yet one kind of evidence cannot be erased so easily: the signatures of energy. Any civilization that reaches the heights of industry leaves behind fingerprints, locked forever in stone, ice, and soil. These energy markers become ghostly signatures preserved long after the hands that made them turn to dust. Take fossil fuels. When we burn coal, oil, and gas, we release carbon dioxide with isotope ratios distinctly different from the natural carbon cycle. This industrial breath becomes trapped in air bubbles inside polar ice, preserved for thousands of years like an archive no historian can edit. Even now, we can measure the imbalance caused by ancient Roman smelting and coal fires of the Industrial Revolution, proof that civilizations leave scars upon the atmosphere itself. The Romans, for example, never imagined that their vast mining operations in Spain would leave a detectable fingerprint in Greenland ice cores 2,000 years later. Yet the lead pollution from their forges still rests there, silent testimony to their mastery of metals. And Rome was just yesterday compared to the vast sweep of time. If they left their mark, what could an advanced civilization from 10 million years ago have left behind? Large-scale projects also write themselves into Earth's body. A dam doesn't just block water. It alters the rhythm of a river, leaving permanent scars in sediment patterns. Quarrying gouges deep wounds into landscapes, visible long after the quarrymen vanish. Cities compress soil, distort drainage, and carve the earth in ways that fossilize into geological permanence. And then, there is nuclear power, the most haunting marker of all. The first atomic test in 1945 seared the desert floor into a strange green glass called trinitite, a permanent reminder of the moment humanity split the atom. For the first time, humans had created something no natural process could mimic. And when we detonated nuclear bombs in the atmosphere between 1945 and 1963, we left a radioactive spike so sharp that 10,000 years from now, future scientists could still pinpoint the exact decade we entered the nuclear age. Now imagine if this wasn't unique. What if another civilization had crossed the nuclear threshold long before us? Would we know? Could a layer of radioactive isotopes, long decayed but still traceable, be waiting to be discovered in ancient rock formations? If trinitite can survive, why not something even older, buried far deeper? But the nuclear trail teaches us another sobering lesson. Even radioactive markers fade. Isotopes decay. Many vanish after mere thousands of years. Only a few, with half-lives stretching into the millions, persist across epochs. If ancient beings had tapped into atomic energy, most of their evidence could already have dissolved into silence. And yet, there are other fingerprints we may be missing. Chemical pollution is one. Synthetic compounds, plastics, fluorocarbons, PCBs never existed in nature before us. They seep into sediments preserved in riverbeds and ocean floors. Could our plastic age be just one more technofossil layer joining countless others laid down by civilizations we've forgotten? More chilling still, what if they had technologies we cannot yet comprehend? Fusion would alter helium isotope ratios. Antimatter annihilation would unleash gamma-ray scars. Exotic energy forms, zero-point extraction, gravitational manipulation, terraforming, might leave imprints invisible to us today, like writings in a language we haven't yet learned. But the most haunting thought of all, the absence of evidence, may itself be evidence. Perhaps advanced civilizations before us developed clean, nearly invisible energy, unlike us. Maybe they didn't scar the Earth with fossil fuels or radiation. Maybe they thrived without polluting their planet to death. If so, their brilliance may have made them harder, not easier, to detect. Yet not all traces are subtle. Climate engineering, terraforming, altering ocean chemistry, all would demand titanic energy expenditures. Such acts would carve unmistakable scars into the planet's fabric as bold as mountain ranges. If they were attempted, the evidence must be there, waiting. But here is the true challenge. Modern geology has not been trained to search for intelligence in deep time. We study erosion, volcanism, tectonics, but not ancient industry. The stone archive of lost civilizations waits to be opened, but only by minds that dare to ask, are we truly the first, or just the latest layer in Earth's hidden history? Just as evolution left fossils of bones and shells, technology would leave behind technofossils, pollution locked in sediments, alloys that resist decay, radiation signatures frozen in crystal lattices. Today, scientists call our current epoch the Anthropocene, defined by human impact. But what if this isn't Earth's first Anthropocene? What if ours is just the most recent chapter in a cycle stretching back millions, maybe hundreds of millions, of years? Imagine this. Millions of years from now, a geologist chips away at layers of ancient rock. Buried within the strata, he doesn't find seashells or fossilized leaves. Instead, he uncovers a fragment of plastic embedded in stone, a concrete slab, pressed flat by time, or a trace of radioactive isotopes that should not exist in nature. These are not the remains of life, but of technology. What scientists today call technofossils. Human industrial activity has already created a geological fingerprint so unique, so alien to the natural record, that it will endure for millions of years. Plastics, metals, concrete, and synthetic isotopes form a sharp dividing line in Earth's geological history, a moment when natural processes gave way to deliberate planetary engineering. But here's the terrifying, exhilarating question. What if this is not the first time? Could there be hidden layers, buried deep in Earth's crust, left behind by civilizations we have long forgotten? Take plastic, for example. Once hailed as a miracle material, it has spread across the globe, like a permanent scar. Microplastics are now found in ocean floors, polar ice, mountain ranges, and even human bloodstreams. Winds carry them across continents. Rivers deliver them to the deepest trenches, and glaciers trap them for millennia. Over geological time, these particles will fuse with sediments, forming rock layers that scream of artificial origins. They will not vanish. They will not decay. They will be our signature to the future. But plastic is only one clue. Consider electronic waste, the discarded bones of our digital age. Inside landfills lie concentrated pockets of rare earth elements, tungsten, cobalt, and lithium, materials ripped from Earth's crust and reassembled in ways nature never intended. When our smartphones and computers are dust, these elemental fingerprints may endure, preserved in mineral veins that no natural process could explain. They would be to future archaeologists what fossilized bones are to paleontologists. Undeniable evidence of something once alive, something once intelligent. And then there are cities, vast concrete jungles, steel skyscrapers, tunnels carved. Through bedrock, roads stretched across continents. All of this reshapes local geology in ways that cannot be erased by mere erosion. Even when our tallest towers collapse and our streets crumble into dust, their buried foundations, subways, and reinforced stone will remain as tectonic tattoos, proof of deliberate design. Think deeper still. Humanity has forged materials meant to survive extremes: titanium alloys, carbon composites, ceramic heat shields. These are not fragile. They are engineered to endure fire, pressure, and time. Imagine fragments of spacecraft, an orbital panel, a jet engine casing, or even a re-entry heat tile lodged within a cliff face, millions of years from now. Would a future civilization believe such a thing natural? Or would it force them to confront the same chilling possibility we now face, that we are not the first? Yet, searching for technofossils is far more difficult than finding bones or shells. Biological evolution leaves consistent patterns, but ancient civilizations may have used technologies utterly alien to us. Materials that decay differently, signals we don't even know how to read. Plastics and steel are our markers. But what if they had theirs? How would we even recognize them? This is where chemistry becomes our guide. Artificial materials often betray themselves through unnatural isotopic ratios or synthetic compounds that no geological process could mimic. Using mass spectrometry, scientists can detect traces invisible to the naked eye. Tiny chemical ghosts that whisper of manufacturing long after the original artifact has crumbled. Even geometry can betray intelligence. Perfect circles, straight lines, and mathematically precise angles rarely occur in nature. A hexagonal crystal forms naturally, yes, but a 90-degree right angle carved into stone is suspect. At microscopic scales, too, tool marks and engineered. Crystal lattices could remain, surviving even when all else is gone. But here's the catch. Science as it stands today is not built for this search. Paleontology hunts bones. Geology studies minerals. Archaeology digs for pottery. What we need is an entirely new field, a forensic science of forgotten civilizations, one that blends geology, archaeology, chemistry, astrophysics, and even artificial intelligence. Without it, the technofossil record may remain invisible, waiting for us to learn how to see it. Why does this matter? Because the stakes are staggering. If we were to discover undeniable evidence of a prior technological species on Earth, it would shatter everything we know about intelligence, evolution, and even our place in the universe. It would prove that civilizations can rise, flourish, and fall, leaving behind nothing but subtle scars in stone. And it would force us to confront an even more uncomfortable truth. If it happened before, it could happen again, to us. One of the greatest risks, then as now, is climate collapse. Advanced societies require stability. Agriculture depends on predictable seasons. Power grids assume consistent weather. Global trade needs safe seas and stable coastlines. But when climate spins beyond control, civilization becomes fragile, and history gives us brutal warnings. Look to Venus, a planet that may once have been Earth's twin, with oceans, clouds, and gentle warmth. But as volcanic outgassing and solar brightening drove carbon dioxide higher, the greenhouse effect spiraled. Oceans boiled. Hydrogen drifted into space. Oxygen fused into rock. The cycle became self-reinforcing until Venus was locked at 900 degrees, its skies crushing, its seas gone forever. What was once a paradise became a permanent inferno. Earth, too, has walked this razor's edge. The Permian-Triassic extinction, 250 million years ago, annihilated 96% of marine species and 70% of land life. Runaway volcanism, methane release, and global warming poisoned seas and skies alike. Later, 56 million years ago, the Paleocene-Eocene thermal maximum raised global temperatures by 9 degrees in only a few thousand years, unleashing migrations, ecosystem collapses, and ocean acidification. Even resilient species teetered at the brink. Now, in our own time, we are pushing the planet even faster. Carbon dioxide levels rise at rates up to 100 times faster than most natural shifts in the record, rivaling the most violent volcanic events. The speed of change may be deadlier than the magnitude itself, leaving ecosystems and infrastructures no time to adapt. If civilizations existed before us, perhaps this is why they vanished. Not by war, not by invasion, but by their own hand, undone by their inability to control the very climate they relied upon. So we are left with a haunting question. If the techno-fossil record is real, buried beneath our feet, are we discovering the fate of another species? Or are we simply staring into a mirror of our own future? Imagine standing on a fragile thread, stretched across an abyss. That is where human civilization exists today, balanced on environmental systems that can only tolerate so much strain before snapping. Energy grids, water cycles, and food systems are all designed with very specific climate conditions in mind. A shift in rainfall patterns or a prolonged spike in global temperatures isn't just an inconvenience. It's a direct threat to the survival of billions. Our technological society, intricate and awe-inspiring, feeds and transports nearly 8 billion people through industrial farming, worldwide shipping lanes, and highly tuned supply chains. But what if this delicate machine is operating closer to collapse than we dare to admit? The truth is chilling. Modern civilization is a castle built on sand. The speed of environmental change, not just the scale, is what makes collapse so dangerous. Historically, climate variations unfolded over thousands, even millions of years. This pace allowed species to migrate, ecosystems to adjust, and evolution to find new balances. But what happens when the shift occurs in just decades? Our systems, both natural and man-made, lack the ability to adapt so quickly. Crops fail, seas rise, coastlines vanish, and once stable societies begin to fracture under pressures their ancestors never imagined. And then there are the tipping points, those invisible lines in Earth's climate system where gradual change suddenly becomes catastrophic. Think of permafrost thawing in Siberia, frozen soil, thousands of years old, now releasing methane, a greenhouse gas far more potent than carbon dioxide. That methane accelerates warming, which melts even more permafrost. Or consider the gleaming white sheets of Arctic ice. Once they shrink, less sunlight is reflected, more heat is absorbed, and melting accelerates further. Forests, too, can become traders in this cycle. Once lush carbon sinks, they transform into raging infernos that spew carbon back into the sky. These feedback loops, once set in motion, continue spiraling long after the original trigger is gone. It may sound theoretical, but history offers us a deadly case study. Venus. Billions of years ago, it may have had oceans, clouds, and perhaps even the ingredients for life. But runaway greenhouse processes transformed it into the hellish world we know today. 900 degrees Fahrenheit on the surface, with crushing atmospheric pressure and clouds of sulfuric acid. Could Earth contain similar switches, hidden and waiting, ready to turn our own world uninhabitable in a geological blink? Ancient civilizations may have stumbled across their own, smaller versions of these catastrophes. Vast agricultural fields, intensive deforestation, unchecked use of resources, all could have destabilized local climates. They might not have known it, but in altering the balance, they may have lit fuses leading to collapse. The geological record whispers of sudden temperature swings, mass extinctions, and ecological crashes. Were all of these purely natural? Or are some the fossilized echoes of civilizations that reached too far, consumed too much, and paid the ultimate price? Yet, even if humanity learned to master climate, the universe has other ways of testing us. Cosmic reset buttons, asteroids, comets, and meteor impacts have struck Earth with unimaginable violence, wiping the slate clean. The most infamous came 66 million years ago. A space rock nearly 6 miles wide slammed into what is now Mexico's Yucatan Peninsula. The energy released was equivalent to 10 billion Hiroshima bombs. Imagine a blast so powerful it vaporized mountains, hurled molten debris halfway across the world, and lit the skies with a fireball that wrapped the globe. Shock waves triggered quakes, volcanoes erupted, and the skies filled with dust so thick the sun disappeared for years. Temperatures plunged into a nuclear winter. Photosynthesis stopped, food webs collapsed, and just like that, the reign of the dinosaurs ended, along with pterosaurs, marine reptiles, and countless other species that had thrived for over 160 million years. But this wasn't the first nor the last cosmic execution. Go back further, 4 billion years, and Earth was pummeled in what scientists called the Late Heavy Bombardment. During this time, asteroids and comets rained down at rates hundreds of times higher than today. Any fragile beginnings of life were likely boiled away again and again as oceans vaporized and the surface reset. Survival was almost impossible, yet somehow life clawed its way through. Statistics reveal a chilling truth. Extinction-level asteroid impacts, those over 6 miles wide, strike Earth roughly every 20 to 50 million years. Not often on a human timescale, but frequent enough to continually reset evolution's progress. The paradox is cruel. Intelligence requires millions of years of steady evolution to emerge. But the universe doesn't wait. Cosmic assassins arrive often enough to shatter civilizations before they can build the tools to protect themselves. In a sense, intelligence is running a race against the cosmos, and history suggests the cosmos wins more often than not. And here's the sobering part. Even the most advanced technology may prove powerless against the largest threats. Nuclear weapons, gravity tractors, even futuristic lasers, these might work on smaller rocks. But what about a mountain-sized asteroid hurtling toward us with the force of entire continents behind it? The energy needed to deflect such an object is beyond anything humanity can currently generate. Worse, some asteroids approach from the direction of the sun, invisible until it's far too late. We may get years of warning, or mere weeks. Either way, against the biggest of them, all our science may be nothing but a candle in a storm. Ancient craters still scar Earth's surface, silent monuments to past catastrophes. Yet erosion, tectonics, and time erase most evidence older than a few 100 million years. Statistically, far more impacts must have happened than we can see today, which leads us to a haunting possibility. What if intelligence, even civilization, did evolve before us only to be erased in a single cosmic instant? What if we're not the first, but simply the first to dodge annihilation long enough to wonder about those who came before? What if the greatest threat to intelligent life has never been war, famine, or disease, but the silent, relentless rain of rocks from space? Asteroids have shaped Earth's destiny again and again, not only ending eras, but perhaps sculpting the very path of intelligence itself. Each strike is like a cosmic clock resetting evolution's timer, wiping clean the slate of dominance and forcing the survivors into entirely new directions. Consider this. If a species does not develop technology quickly enough to defend itself from the heavens, then it may be destined for extinction. Evolution, in this view, is not just about survival of the fittest, it is survival of the fastest. Learners. Civilizations that master the skies, mathematics, and engineering rapidly enough might stand a chance to endure. Those that linger too long in the Stone Age may never see the next sunrise after the cosmos delivers its inevitable blow. And yet, destruction is not the only gift asteroids bring. When a meteor slammed into Earth 66 million years ago, it annihilated the dinosaurs. But in that fiery void, mammals, small, fragile, overlooked, rose to fill the vacant niches. Without that single cosmic disaster, human intelligence as we know it might never have existed. Catastrophe can also be a cruel kind of creation, forcing evolution to accelerate in ways steady natural selection never could. This raises an unsettling possibility. What if asteroid cycles have been shaping not just the evolution of species, but the rise and fall of civilizations? What if humanity is not the first technological species on Earth, but merely the latest survivors of a pattern that stretches back millions of years? Look closer at the record. Humanity's sudden burst of intelligence is baffling. For millions of years, our ancestors chipped away slowly at stone tools. Then, in a breathtakingly short span, barely 100,000 years, we developed language, art, agriculture, astronomy, architecture, and technology. That pace defies ordinary evolutionary logic. Was this simply pressure from catastrophe? Or was it the reawakening of knowledge long forgotten? Archaeological anomalies whisper of something older. At Puma Punku in Bolivia, massive stones lie scattered like the wreckage of giants, cut with such precision that modern engineers marvel at the technique. How could supposed hunter-gatherers have carved and moved these blocks without advanced tools? At ancient sites across the world, from Giza to Göbekli Tepe, monuments align perfectly with astronomical events, demonstrating mathematical knowledge far beyond what textbooks credit to early humans. Are these the fingerprints of lost civilizations, or fragments of a knowledge stream passed down across cycles of destruction? And listen to the stories our ancestors left us. Hindu cosmology speaks of vast ages, cycles of creation and destruction, stretching across millions of years, in which humanity rises and falls again and again. Greek myths tell of golden ages when mortals walked with gods who wielded unimaginable technologies. Native American traditions speak of entire worlds that ended because humans became too advanced, too arrogant, too destructive. Could these be echoes of real civilizations remembered as myth, so the knowledge would survive the erosion of time? Science, too, whispers agreement. Genetic studies show that humanity nearly vanished multiple times in the last 100,000 years. Bottlenecks where fewer than 10,000 individuals survived. Events that coincide eerily with volcanic winters, asteroid strikes, and violent climate shifts. If advanced cultures existed then, their traces would have been obliterated. Imagine, skyscrapers turned to dust, satellites melted into ash, entire libraries lost forever. 1,000,000 years later, would we even know they had been here? History provides chilling parallels. The burning of the Library of Alexandria. One fire, one accident of war, erased centuries of knowledge. Now imagine that multiplied across entire continents. What if such losses weren't accidents but cycles? Civilizations rising, amassing, knowledge, only to have it torn away by fire, flood, or skyfall. Even ancient texts record technologies that sound suspiciously modern. The Sanskrit epics speak of vimanas, flying machines powered by forces unknown. They describe weapons of fire and sound communication devices that echo our radios and missiles. Were these pure imagination, or faint memories of technologies long buried beneath sand and myth? And consider how modern innovation often unfolds. Electricity, calculus, the steam engine. Many breakthroughs were discovered not once but multiple times by independent inventors across the world. Could it be that some discoveries are not entirely new, but rediscoveries of principles once known, lost, and then found again when the time was right? If so, then the story of humanity is not a steady climb, but a cycle, a spiral of rise, collapse, and renewal. Perhaps hidden beneath the earth lie sealed repositories of knowledge, caches of artifacts waiting to be found. Ancient texts hint at such vaults, guarded by secret orders or concealed in mountains and deserts. What might humanity uncover if such a trove were opened? The patterns of history suggest a sobering truth. Rapid technological advancement often precedes collapse. Civilizations push past the limits of their environment, weaponize their brilliance, and fall beneath the weight of their own inventions. Are we next in line for such a fate? Or will we, unlike our forgotten predecessors, finally break the cycle? For the first time in Earth's history, we have tools they may not have had. Satellites to watch the skies, rockets to take us beyond them. Global communication that can preserve knowledge across continents, across disasters. And yet, the same technology threatens us with nuclear fire, artificial intelligence risks, and ecological collapse. Will our brilliance save us or doom us? The haunting question remains. Are we truly the first, or simply the latest in a long lineage of civilizations erased by time? If others came before, then their greatest gift to us may not be technology, but the warning embedded in their silence. If we are not Earth's first civilization, then this realization is not just an archaeological curiosity. It is the final exam of humanity. The moment that decides whether we step forward into the rare ranks of species that endure beyond their cradle, or whether we collapse into silence and rubble, becoming nothing more than another erased chapter in the endless cycle of intelligence that rises, burns bright, and vanishes into ash. The clues we've uncovered whisper of civilizations older than memory itself. Ancient nuclear reactors that ran 2 billion years ago beneath the soils of Gabon. Silent evidence of minds that harnessed atomic fire long before us. Mass extinction events that strike not with the slow hand of nature, but with the sudden surgical force of catastrophe. Isotope signatures in stone hinting at industrial activity no natural process could explain. Climate upheavals eerily similar to the crisis we now face. Each fragment suggests the same chilling truth. Intelligence has walked this earth before. They discovered fire, built machines, perhaps even gazed at the stars. Yet they fell. And time buried their brilliance until only subtle fingerprints remain, etched into rocks, ice, and the scars of Earth's memory. But unlike them, we hold something no previous civilization possessed: awareness. They walked blind into their doom, never knowing others had already failed the same trials. We, however, stand at a crossroads lit by warnings carved into the very bones of the planet. The geological record becomes not just history, but a survival manual. Every collapse etched in fossilized remains is a warning. Every anomaly is a message. Every vanished civilization is a teacher we can still choose to learn from. The Great Filter, that invisible wall that explains why the universe appears silent despite its billions of stars, may not be a single event at all. It may be a gauntlet, a staircase of challenges that grow sharper and deadlier with each step. Early filters test whether a species can use tools without destroying its world. Later filters test whether nuclear fire or artificial intelligence devours its creators. The final filters demand more. Can a species outlast its own sun, its own planet, its own fragile cradle? And now, humanity's hour has come. Our world is heating, seas are rising, forests are vanishing. Technology grows faster than wisdom, creating weapons that could end us in seconds. Social systems strain under the weight of change. The warnings are all around us, the very same shadows that may have swallowed those who came before. Yet, unlike them, we wield unprecedented powers. We can speak to one another across the globe in seconds. We can map the heartbeat of the planet from orbit. We can reach beyond Earth, planting seeds of survival on other worlds. We can build defenses against asteroids, the very cosmic hammers that may have struck intelligence down before. For the first time in history, a civilization may not be bound to the cycle of rise and ruin. But the question is, will we use this advantage in time? The search for ancient civilizations is no longer just curiosity. It is survival research. If minds before us left behind messages, artifacts, or wisdom hidden in the deep earth, we must find them before they vanish forever. What if there are caches of knowledge buried beneath ice sheets, or locked within lunar craters, or even encoded in DNA? Could the final key to humanity's survival already be waiting, hidden in plain sight? Time, however, is our greatest enemy. The same forces that preserved faint whispers of the past also erase them. Tectonic shifts, erosion, rising seas. Human industry itself destroys what little evidence may remain before we even know it exists. And as we search the stones for their stories, our own civilization teeters at the edge of repeating the same mistakes. Perhaps the truest measure of intelligence is not invention, but wisdom. Wisdom to wield power without succumbing to it. Wisdom to think not in years or centuries, but in geological ages. If civilizations before us failed this test, then they vanished into the cosmic silence. But maybe, just maybe, some succeeded. Perhaps they transcended their worlds, spread beyond the fragile cradle of their birth, and now watch, waiting to see if humanity will join them or follow. The same road to oblivion, and so the test begins. Right now, every choice we make, every technology we build, every resource we consume, every war we wage or peace we keep, it all leads toward one answer. Will human consciousness be nothing more than a brief spark, a flicker swallowed by darkness? Or will we light the universe, not for a moment but forever? The choice is ours, but it will not be ours for long.